All right, good morning. Today we're going to learn about the intercept form of a quadratic. So the intercept form of a quadratic function is f of x equals a times x minus r times x minus s. Okay, so converting between forms, this is standard form here, where you've got no parentheses, ax squared plus bx plus c. Vertex form, standard form is what you would see normally as a polynomial. Vertex form is a times x minus h squared plus k. This gives you the vertex, which is at hk. It also gives you the a value if there's a stretch or a shrink. That's the same in standard form. It gives you the a value, which is a stretch or shrink. It does also actually give you the y-intercept, which is c. And then the intercept or factored form, this gives you a, which is your stretch or shrink. And it also actually gives you your two intercepts, your x-intercepts, which are at r and s. There might only be one, and there might not be any, so we'll talk about that. So to find the x-intercepts from intercept form, set each of the factors equal to 0 and solve. Now the reason that works is because if you look at the intercept form, like here, if that factor was equal to 0, it would be 0 times something, which is 0, times something, which is still 0, because 0 times anything is 0. So if you set the f of x equal to 0, then you can find out what the factors would each be equal to. So for example, we have two factors here, x minus 2, and we also have x plus 6. So we're going to set each of those factors equal to 0, and we're going to solve for x. So in the first one, I have x minus 2 equals 0. I'm going to add 2 to both sides, and I get x equals 2. But we write x-intercepts as x comma 0. So your x-intercept here would be 2 comma 0. For the next example, x plus 6 equals 0. I'm going to subtract 6 from both sides, and I get x equals negative 6. So that x-intercept is at negative 6 comma 0. Example 2, I still have two factors, x and x plus 3. Set each of your factors equal to 0 and solve for x. For my first example, x is equal to 0. There's nothing to solve for. It's already solved. So that intercept is at 0, 0. For x plus 3, I'm going to subtract 3 from both sides, and I get x equals negative 3. So that intercept is at negative 3, 0. Example 3, two factors, negative x and x plus 5. If I set negative x equal to 0 and x plus 5 equals 0, if I solve for the negative x equals 0, to solve for that, you divide both sides by negative 1. And 0 divided by anything is 0. So this also has an x-intercept at 0, 0. For x plus 5 equals 0, I'm going to subtract 5 from both sides, and I get x is negative 5. So that x-intercept is at negative 5, 0. For the fourth example, I have 1, 2, 3 x-intercepts, or 3 factors, sorry. So I've got 4 equals 0, x plus 8 equals 0, and x minus 9 equals 0. For 4 equals 0, there's no x here to solve for. So that does not an x-intercept at all. To solve for x plus 8 equals 0, you're going to subtract 8 from both sides, and I get x is negative 8. So that x-intercept is at negative 8, 0. X minus 9 equals 0, I add 9 to both sides, and x is 9. So that x-intercept is at 9, 0. Remember that you have 0, 1, or 2 x-intercepts. So this graph looks something like this, negative 8 and 9, and it has intercepts like that. For example 2, I've got an x-intercept at 0 and at negative 3. So this one looks something like this. For example 1, I have x-intercepts at negative 6 and 2. Looks like that. But for example 3, I have an x-intercept at 0 and one at negative 5. But this negative at the very front tells me that this opens downward. So this has x-intercepts and it looks more like that. To convert between forms, we want to convert this to standard form. So